Hey everyone, welcome to our next video. Let me go over to our notes. Oh, there we go. Alrighty. So this video is over 5.2. This is Law of Cosines. And I brought up Law of Cosines a little bit in the last video. So 5.1 is Law of Sines. 5.2, Law of Cosines. So again, we're dealing with oblique triangles, meaning we have no right angles. And again, no right angle means that we can't use Pythagorean theorem and we can't use like the normal relationships of sine, cosine, and stuff like that because they involve a hypotenuse. And if we have no right angle, we have no hypotenuse. So we can't use any of that. The two cases that we're going to see that we use law of cosines for is side, angle, side, and side, side, side. So with both of these cases, you can see that you won't have a fully developed ratio, meaning like an angle across from its like respective side. Because of that, like that's why you can't use law of sines right away. Now I want to exercise some caution here. So with side angle side, there's only going to be one option that you're going to be able to get out of this. It's going to be the side across from the angle you're given. So that one you're only going to have one option of where to start. With side, 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 you can actually go any of the other angles first. So you're actually going to have some choices. And when we have choices of what we can get first and stuff like that, we are going to have to be pretty careful. So let me write out for you what the law of cosines looks like. So it says a squared is equal to b squared plus c squared. That actually looks a lot like Pythagorean theorem, but there's more to it. Minus 2bc times cosine of angle A. So this is one version of the law of cosines. There are other versions as well. So for instance, maybe I don't want like to find side A or something like that. What if I want B? Well then that would be a squared plus c squared minus 2ac times cosine B. So what you'll notice is this side should be across from this angle. And then the other two sides that are involved are the ones surrounding your angle. Or like adjacent to your angle. So then if I write it with c squared, it would be A and B as my sides. And then my angle would be C, since it's across from side C. I don't believe that you need to remember all of these. I think you can kind of just know one and then know how to get to the others. Like I don't know. I don't really see them as like super separate. I think it's really easy to get to the other ones if you just know one of them. However, um, I do not plan on giving this formula for test 3. I also don't plan on giving the law of sines formula. The reason I don't want to give this one is one quarter I actually did give the formula and I had more mistakes on the question than any other quarter. I think because I gave the formula. Because what happened is like people would just look at the one formula I gave, which I think I gave this one. And then if they had to like find B or something, they would just try to solve it for B instead of actually using the different formula that has B right here. I hope that makes sense. If not, you just have different versions of the formula that you can do. You don't need to actually like solve it for a different letter. The only time we're really going to solve these is if we're looking for an angle. If we want an angle, then yeah, we're going to have to solve it for that angle. And let me go ahead and show you how to do that right now. So let's say that I want to solve this for angle A. Like maybe I have the side, side, side case, and I need to find my angle, and I know all my sides. So I'd start off with a squared equals b squared plus c squared minus 2bc times cosine a. So I'm trying to get the a by itself, so I'll have to get cosine a by itself. First, I can subtract the b squared and also the c squared. So let me write what I have now. A squared minus b squared minus c squared equals negative 2bc times cosine a. So I'm just trying to get cosine a by itself. Right now, this is all multiplied by cosine a, so let's go ahead and divide it to get rid of it. So I'm left with a squared minus b squared minus c squared over negative 2bc is equal to cosine of a. And remember, when you're looking for an angle, you're going to use the inverse function. So we're going to have to do a, let me rewrite this, a equals cosine inverse of that whole other side. So a squared minus b squared minus c squared over negative 2bc. So this is that formula solved for angle A. And I could do the same thing with angle B and angle C. It would be the exact same steps, it's just the letters would be different. I also want to recommend that when you're plugging this into the calculator, like as we do examples and stuff, I recommend putting parentheses around the numerator and around the denominator by themselves, just to help not have like a calculator error. So we're going to have to be a little careful here. The reason is whenever you use law of cosines one time, you are going to have a fully developed ratio at that point. A fully developed ratio means you're going to have an angle across from its side. Your homework in the textbook is going to tell you that if you have an angle across from its side, you should switch to using law of sines. I think you should exercise a lot of caution when doing that because I see a lot of times people will end up with the wrong answer. And the reason is because cosine and sine are positive in different quadrants. So if you are using law of cosines and then you suddenly switch to law of sines, if you're not careful about the order in which you find your angles and sides, you could end up with the wrong answer. I'm going to show you an example of this happening. And sometimes it's kind of hard to tell like when it's going to happen and when you're safe. So you'll just have to be careful. And I just don't recommend switching to law of sines. That's my honest opinion on it. Because if you have to be so careful and picky about the order in which you do certain stuff, I think y'all are going to forget that. So if you just don't switch to law of sines, you won't have an issue. I'll show you what I mean when we do an example. So with that, let's go ahead and start our first example. It says given A is equal to 8.2, B is equal to 3.7, C is equal to 10.8, solve the triangle. And I usually will give you rounding directions on these triangles. So let's go ahead and say rounding to the nearest, let's do 10th for this one. So on the test, I'm going to give you I'm going to tell you when you need to round and when you don't. The reason I do that is so that you can know oh, if she says something about rounding, I probably need to use the calculator for this one. But if I say something like exact answer, then you don't want to use the calculator for that question. So first, I should always draw out my situation. So let's see, I've got A, we'll put C up here, we'll put B here. So B is 3.7, A is 8.2, C is 10.8. So we can find whatever one we want first. The reason we can find whatever one we want first is because I'm not going to switch to law of sines. I'm going to stick with law of cosines and show you that there's no issue if you do that. So we can go find whatever we want. Usually if we were in a class, I would ask y'all which one you want to do. I'm going to say let's just go get A first. Why not? So I'm going to go find A. So because I have a side-side-side relationship, I know I need law of cosines. So I'm going to write out my law of cosines. A squared equals B squared, plus C squared minus 2BC times cosine A. Now I need to solve this for angle A. So just like I did earlier, I'm going to subtract these two. Then I divide by negative 2BC. And then I use the inverse cosine. That way I can get my angle. So this is going to be A is equal to cosine inverse of all that other stuff. So I'm going to go ahead and plug everything in. So let me come up here and do that. So I have A is equal to cosine inverse. Oh, I hope I have enough space. Whoops, I didn't really think about that. So A is 8.2 squared minus B, which is 3.7 squared. C is 10.8 and then squared divided by negative 2 times B, which is 3.7, times C, which is 10.8. So like I said, I do recommend writing an extra parentheses for the numerator and also for the denominator. So that's exactly how I would type it in. I would have cosine inverse. If you want me to write it out in a row, I can. So let me go ahead and maybe do that. I don't know if you would find it helpful. Some people do. So I would literally write out cosine inverse, parentheses, parentheses, 8.2 squared minus 3.7 squared minus 10.8 squared, close parentheses, divided by, open, negative 2 times 3.7 times 10.8, close, close. So that's like exactly what I would type in. So for my angle A here, let me go ahead and type it into my calculator and see what I get. Some common mistakes people can make in the calculator. 1 parentheses. So I get 37.9 for this one. Parentheses, or make sure when you type in this little negative symbol right here, you actually type in the negative one, not the subtraction button. So sometimes that can be an error in the calculator. Just be careful. All right. Now we can go get whatever we want as long as we stick with law of cosines. If you switch to law of sines, which I'm going to show you, you could run into issues. So let's see, we're going to just stick with law of cosines. So I'm going to find, let's go get C next. Why not? I don't have to be picky about the order as long as I stick with law of cosines. So for C, I would have to use the one that starts with C. So C squared equals A squared plus B squared minus 2AB times cosine C. I'm going to quickly solve this for angle C. So this would be cosine inverse C squared minus A squared minus B squared over negative 2AB. So I know that I did that without really showing any work, but it is the same like solving steps as before. So I get C is equal to cosine inverse, and now I'm going to plug everything in. So my C was 10.8 minus my A, which was 8.2, minus my B, which is 3.7, over negative 2 times 8.2 times 3.7. And when I put this in the calculator, I'm going to do some extra parentheses here. So let's see. If you at all have any issues plugging into the calculator, please let me know. That's probably something I would want us to probably schedule a meeting for so that I can see what you're actually plugging in so I can help you out. All right, so I got 126. Oh, let me switch my color. 126.1. I'm rounding to the nearest tenth. Now finding your last angle is easy. To find my last angle, since I already have two other angles, I can just do 180 minus A minus C. So I don't actually have to use law of cosines for the last step. I get 16 degrees for this one. So there we go. I got all of my angles. Now I want to show you if we had switched to law of sines, when we did finding angle C, what could have happened? Like what we could have messed up. So this is what the homework will tell you to do. So when finding C, we're going to look at, instead of when I found C, because technically when I found my A, I have a fully developed ratio. So it's technically okay for me to switch to law of sines. So I would have sine A over A equals sine C over C. If I solve this, so I plug everything in, so I've got sine of A, which was 37.9, over A, which was 8.2, is equal to sine C, which I'm looking for, because we're pretending like we don't have it. We're doing it different. Okay. If I solve this for C, which you can look back at the solving steps in 5.1 if you need to, I'm going to do it fairly quickly. So I get sine C is equal to 10.8 times sine 37.9 divided by 8.2. So C is equal to sine inverse of all that stuff. All right, let's see what this gives me. Ooh, 54. That is incorrect. That is incorrect. Because we found that C is supposed to be 126.1. So it's like, how does that even make sense? And then you would have had the wrong B value as well. Now I'll tell you how you can check yourself, okay? If we had then found B, so we would have done 180 minus A minus C, just like we did before. If you do this, you end up with 88.1 as your angle B. Okay, so I hope you can pay attention to this. And I'm going to kind of recap at the end as well. If you look at what I did in the green, so I never switched to law of sines in any of that. If we check any of our angles, we can see that my biggest angle is angle C, and it's across from my biggest side. And then my smallest angle is angle B, and it is across from my smallest side, which is side B. So all of that checks out. If you look at what I did in the blue, you can see that our biggest angle looks like it's B, but B is the smallest side. So that does not make any sense. It doesn't make any sense for the biggest angle to be across from the smallest side. So that's how I would know that switching to law of sines right there would have been the wrong way to go. Now, if you had found angle B next and used law of sines, it actually would have worked. And so that's why you have to be really careful. And it's a little hard to explain, honestly, like when it's okay and when it's not okay to use law of sines in a side angle side or side problem. So I really hope you can just maybe not switch to law of sines. I know it will be tempting because that's what the homework and stuff is going to tell you to do. You just have You just have to be careful because I see it all the time. Students coming out with the wrong answers. In general, a way you can avoid this, so with the homework and stuff in the textbook says to do, is it says to find your biggest angle first. Then you're supposed to find your smallest angle. And then you find your last angle. So if you want to switch to law of sines, you'll have to be picky about the order in which you find your angles. I find that usually students will forget to do that. So, got to be careful. You just got to be careful. I really hope this made sense. In general, don't switch to law of sines. That's really just my advice. I know that a lot of textbooks and stuff they say to do it, but you have to be careful. And if you do switch to law of sines, at least check your answer. The correct thing that you're supposed to do here, if you found that your C is actually wrong, is you're supposed to do 180 minus it, and that's how you fix it. Is you do 180 minus that angle. But you can't know that the angle's wrong unless you just find all of them, and then you can go check your answer at the end. But that might confuse you on like a test, so I don't know. Just be careful. I really can't say that enough. Choose what works for you. But let's go ahead and do another question. This one we're going to do a side angle side case. So this one says given A is equal to 6.8, C is equal to 2.4, B is equal to 10.5 degrees. We're going to solve the triangle. I always just draw it out first. Put everything pretty much wherever you want. I don't know. Let's put C here. So C will be 2.4. Let's put A up here. So it'll be 6.8. And then we'll put B here. And they told us that was 10.5. So I'm seeing a side angle side case. When you have side angle side, and you try to use law of cosines, if we look at like our formulas, so I'm going to come back up to the top for a second. We have A, capital B, and C. So if I come back up here, the only one that has A, C, and capital B in it, like on the one side, is this one. So I'm going to have to find angle B. So what you end up doing is you end up making a fully developed ratio. So we're going to go get side B. So we get B squared is equal to A squared plus C squared minus 2AC times cosine B. Let me put my little, what I'm looking for here. All right, looking for B, side B. So I'm going to plug everything in. All right, so I got everything there. Now I'm going to have to find B by itself, so I am going to have to take the square root. I'm just going to go ahead and do all this in one step. It's not too bad to plug into the calculator. It's going to open up its own parentheses for all the stuff inside the square root. So all you got to type in is the rest of it. So I'm typing it in now. I'm going to see what I get. pause and maybe you type it in and make sure you get the same thing as me. I'm about to write what I get. I got 4.46. And I don't know, let's say that I want to do 2 decimal places for this one. That's usually my standard is 2 decimal places. Just do whatever the homework tells you to do. On the test, like 1 or 2 is fine. I usually say 2, but I'm not like super picky about it. As long as you don't put like 4, that would be bad. I need at least 1 decimal place. So now we technically have a fully developed ratio because we have b. So you may be tempted to go ahead and switch to law of sines. I'm going to tell you a little something about this question. This was actually a test question on my spring, so just last quarter, on that test, and I probably had like half the class get it wrong because they switched to law of sines after I specifically said, please be careful about switching to law of sines. You might get the wrong answer. And it definitely happened. So. But hopefully I can teach you how to avoid it from happening, or at least check your answer to know that it was wrong. But really for this one, I just wouldn't switch because you have to decide at this point, do you want to go get A or do you want to go get C? If you switch to law of sines and you try to go get A, you're going to get the wrong answer. If you get C, you get the right answer. So it's like, how do you choose? How do you pick which one you're supposed to go get? And it's really based on the angle, like the sides, and which angle is going to be bigger and which angle is going to be smaller. But sometimes it's hard to remember to do that. So don't switch and you won't have a problem. So let's go ahead and I can do whichever one because I'm not going to switch. So let's go ahead and find A. So for A, I'm going to have to use the one that starts with A squared. So I'm going to write that out. And I'm looking for angle A, so I am going to have to solve this for angle A. So let me do that. I'm just going to write the result because I have solved this one a few times now. There we go. Plug in all my values. Four 4.46 and then C 2.4. There we go. And these dots here, I mean, those are my multiplication signs. All right. So I get A is, and you go ahead and try it out. Pause the video. Try to do it yourself. I will tell you that I'm not going to round that 4.46. I already have the value in the calculator, so I'm just going to use the answer button where it pulls like the previous question. That way I don't round. So if you're off by a little bit from me, it's okay. Without rounding at all, I got 163.87. And then for my last angle, I gotta go get angle C. So for that, I'm just gonna do 180 minus the other 2. And so this gives me, oh, let me write it in. 5.63. Forgot my little degree symbol. And there we go. Now again, you can check yourself and you can say, okay, my biggest angle is A and it's also across my biggest side, so that's good. My smallest angle is C and it's across from my smallest side, so that's good. And then my middle angle is B, it's at 10.5 and it's across from like the middle side. So this is good. There's probably no issues. Now, I will show you this. You don't have to write this by any means, but I do just want to show you. If you had used law of sines, what would have happened if you went and found A first? So you would have done sine of A over A is equal to sine B over B. I can plug everything in. So I'm just showing you like what would have happened if you had switched to law of sines. I'm not showing too much work here. I'm just kind of writing the bare bones of the formulas. Because I just want to show you. I got 16.13. And that's not right at all. That would have made, so then if I do that, like if that's my A, and then if I go find C at that point, the value for C that I would have gotten would have been 153.37. And if you look at the triangle, that doesn't make any sense. C is supposed to be the smallest side, so it's supposed to be the smallest angle. This is telling me that C is my biggest angle. That doesn't make any sense. So that's how you would know, like if you do switch to law of sines, how do you know if you shouldn't have or if you found the wrong side or the wrong angle or something? It's based on that, like the sides of what is smallest and what is biggest and the angles of what is smallest and what is biggest, they don't match up. They don't make any sense. But I will tell you that what I wrote in blue, probably like half the class did it in the spring. And I was a little disappointed because I was like, I said not to do that. But it's okay. I mean, it happens. But if you check it at the end, it really doesn't make any sense. So there you go. You can choose at this point if you want to switch to law of sines or not. If you do and you end up with like it not making sense, you would just have to do 180 minus it. And that's it. So it's actually a pretty easy fix. 180 minus A would have given you 163.87. So you can fix it fairly easily if you do switch to law of sines. So, but you have to be able to recognize that it was wrong to start off with. All right, let's get into just some more problems. I'm not going to keep talking about the whole switching to sines thing. I think I've driven it home. I think you get the point. If I do see it on test 3, I'll be like, oh my gosh. So don't do it. Or if you do it, just do it carefully and notice if it's wrong. Oh my goodness. Sorry. All right, let's go ahead and do another one. This one says the wing of a spaceship is triangular with two adjacent sides measuring at 37.6 feet and 19.2 feet. The angle included between these sides measures 68 degrees. What is the length of the remaining side? Okay, go ahead and pause and write that down. I'm going to go ahead and get started and write out everything. All right, so wing of a spaceship. I don't know, something like that. I'm literally just drawing a triangle because that's what it says it is. But it says two adjacent sides measuring at 37.6 and 19.2. And it really doesn't matter where we put that. I'll do 37.6 and 19.2. You could have put them wherever you want. But they're adjacent, so they need to be like next to each other. I know that. Now the angle included between these sides measures 68, so that means it's got to be between them. And we're looking for the length of the remaining side, so I'll go ahead and call that, I don't know, x, whatever. And so what we're seeing here is a side angle side relationship, so we're going to have to use law of cosines. You can always try to use law of sines, but what you'll see is without a fully developed ratio, like an angle across from its side, you can't use it. So that's when you would be like, oh, got to use law of cosines. So the formulas say that it's going to be, so the formulas basically follow like a side angle side relationship. So if I'm looking for x, it would be x squared. And then on the other side here, it would be my two angles squared and then added together minus 2 times those two sides. And then the angle inside of cosine is the one across from this side. So that's going to be 68. So this one, I just want to show you, like, you don't actually have to, like, use one of the formulas. You can, but I wouldn't get super picky on, like, what's A, what's C, and stuff like that. It just is following the side angle side relationship. And maybe that would help you. Maybe it wouldn't. Maybe for you, you're like, no, I really need to see it, like, with the letters that we always use. So if that's you, you can always just label it. So you can say that this is A, say this is B, and say this is C. And so this would have to be angle C. And so then we could use that formula, C squared is equal to A squared plus B squared minus 2AB times cosine angle C. And then you can plug it in that way, but we're getting the same stuff. So whatever kind of strategy you like, if you're really strict on using the formulas, that is okay. Um, yeah, whatever works for you. And so I'm looking for that x or c, whatever we want to call it in this case. And so I'm going to take the square root of both sides. And I get x is equal to, and then I'm just going to plug all that other stuff in. Make sure you do take the square root. I almost forgot to just now. 35.2 is what I got. And that's it. Now something you'll notice here is like, so see how I put A as 19.2, but then it's looking like when I first did it, like I had switched them. It's okay because addition is commutative, so it doesn't matter which one you add, like which one you're putting in as A, which one you're putting B. And then so is multiplication, so it ended up okay. But again, I just want to say, like, if you are really picky about using the formulas, like, you have to stick strictly to them to understand them. That is okay. I'll just switch them on my little picture. I guess I just get a little concerned if you don't understand, like, the side angle side relationship, right? Because this is like the two sides, and then this is just the included angle. And so if you know that, then you don't have to remember, like, all three different formulas. You know what I mean? Like if you're being given different letters or stuff like that. I hope I'm not confusing you. If I am sorry. I probably gave way too thorough of an explanation for that. And this one was nice though because they only wanted that other side, so we're done. We don't have to do anything else. For my next example, we're going to talk about like the length of a chord. So this is kind of an application of using law of cosines. So length of a chord. First, I need to ask you, do you know what a chord is? And obviously you can't answer me, but you can just kind of say it to yourself. So if we have a circle, it'll have a central point. And so a chord is just a line that touches one part of the circle to another part of the circle, like on the outside. Let me color code a little bit, actually. I'm going to do that in pink. So this is a chord. And I'm going to go ahead and call that chord C. So technically, like a diameter is a type of chord. It's just one line going through to the other, touching like another part of the circle. If it goes through the center, it just happens to be called a diameter. So if I have this information, I can also remember that I have a radius. So I can draw a line from the center to each of these points on the outside. And so I'm going to call that R. Those are my radius. And then I can have this angle on the inside, which I'm going to go ahead and just call C since it's across from C. And that's going to be like my central angle. So if I want to find like the measure of C, and let's say that I know angle C and I know both, like I know my radius. Let's say I know those things and I want to find how long the chord is. I can use law of cosines to help me with this. So let's see. Law of cosines says c squared is equal to a squared plus b squared minus 2ab times cosine c. And so I'm keeping my c squared, but now my a and b, like my other two sides, they're r in this case. So I'm going to go ahead and change those out. And I'm going to keep simplifying this. So r squared plus r squared is 2r squared. Negative 2, and then r times r is r squared. Then I can technically factor out an r squared. We could have factored out a 2 as well, but I'll show you in a second why we didn't do that. My last step here, if I'm solving for c, is I want to take that square root. Square root of r squared is just r, and then I'm left with everything else in the square root. That's why I didn't want to take out the 2 with the r squared, because I was planning to like take the square root. So pretty much, this ends up showing us a new formula that we can use if we're looking for the length of a chord, where maybe we don't need to start off with the whole like law of cosines. We just have a little bit easier of a formula to work with. And I'll show you an example of like what we would do with this. So I think this is example 4. So a regular pentagon is inscribed in a circle of radius 6 inches. What is the length of a side of the pentagon? And you can go ahead and pause and write that down. I'm going to start talking about it though. The fact that it's a regular pentagon, well, pentagon, what is that? How many sides does it have? So that's 5 sides. The fact that it's regular means all the sides are the same length. And if it's inscribed in a circle, it's meaning like it's perfectly done to where the points of the pentagon are touching the points of the circle. So let me go ahead and draw this out as best as I can. This is, we'll see. We'll see how good it is. That's actually not that bad of a circle. I'm a little bit proud of that. Just a little. One of the sides is a little wonky. That's all right. So let's go ahead and draw a pentagon in here as best as I can. It's gonna look terrible. It's okay. Let me do it another color. All right. Going strong. Okay, not even that bad. Not even that bad. When I draw that in class sometimes, like on the whiteboard, oh my gosh, it just looks awful. And so we do have this point in the inside, right? Because all circles are going to have like a center point. And it also talks about my radius. So remember that the radius is going to go out to each of these points. And it also says that the radius is 6. So that means all of these have a radius of 6. So what I'm looking for right now is I'm looking for the side length. So I'm looking for this, let's call it C. And now I need to figure out, can I find angle C? So can I figure out what this angle right here is supposed to be? So I want you to think about this for a second. How many angles are in a circle? So there's 360 degrees. I should have said degrees, not angles. 360 degrees in a circle. And then we've broken our circle up into 5 like sections. So we can take our 360 and divide it by 5, and that gives me 72 degrees. So that's what each of those little sections is going to be. So now I'm going to find C. So I'm using the formula we had earlier. So C is equal to R square root 2 minus 2 cosine of angle C. And I'm just plugging it in. I get 7.1 for my answer here. So that's roughly how long each of the sides of this pentagon are. And it's in inches because the radius was in inches, so we're still in inches. And so there's a homework question that's a little similar to that. It's just one way you can like use law of cosines to help you out. There's one more question that I would like to do that is very similar to a homework problem. So example 5, it says Jan and Dean start a hike from the same location at the same time. Jan hikes 4 miles per hour, bearing north 12 degrees east. And Dean hikes 3 miles per hour, bearing north 31 degrees west. Find the distance between them after 5 hours. And you can go ahead and pause and write that out. This is actually not as bad as you would think. I feel like it looks harder than it really is. First thing, because it's talking about bearing, we kind of need to draw like a compass. So north, east, oh, my E was terrible. East, south, and west. And so if it says that they're starting at the same point, we're going to go ahead and start them from the origin. So I'm going to do Jan in green. So she hikes north 12 degrees east. So what this is saying is she's mostly going north, but she's about 12 degrees over to the east. So this inside here is 12 degrees. And then Dean, I'll go ahead and do in blue. He hikes 3 miles per hour bearing north 31 degrees west. So he's doing mostly north, but he's going a little bit further west by 31 degrees. So that's how we're going to be able to draw this. Now what I'm looking for is this right here. I want to know after 5 hours, how far apart are they? Now it's looking like I have my central angle, but we have to figure out like what are the side lengths for this. So think about this. If Jan hikes 4 miles per hour, how many miles does she hike after 5 hours? So Jan, right, is 4 miles per hour for 5 hours. So how many miles is that? So we would do 4 times 5, so that's 20 miles. So her side length here is going to be 20. Now Dean hikes 3 miles per hour for 5 hours. So that's 3 times 5, so 15 miles. And so from here, you have everything you need for your triangle. So we have 15, 20, and then this inside here would be 43 if I add them together. So this is your triangle that you're trying to find that opposite side from 43. So it's side angle side. So you're going to go ahead and use law of cosines. Now I'm not going to finish this one out. I just kind of wanted to help you set it up because it's just one of the homework questions I've seen that I think you could use a little help on. So if you have any other questions, of course, let me know. I'm always here to help. Yeah, but that's going to be it for 5.2, and I hope that y'all are having a wonderful day. Bye-bye.